So good evening, everyone, and welcome to this session. Wants to welcome each and every one of you. So as our tradition pertains, we're going to go through a couple of things. Who are those who wants to respond to the question? Walk me through the steps from when you added this until when it's available to use, or passwordless authentication. Can we have some volunteers? Miss Patience, do you want to go?
No, sir, I'm not prepared. I don't feel well.
Oh, sorry about that.
Thank you.
Who wants to go? Miss Pale, are you there?
Oh, sorry, sir. Can you please pass me?
Okay. Any volunteers? Joyce, how about you?
Sorry, sir, I'm not prepared.
All the ladies are letting us down. Let me move to the boys. Ernest, are you ready to present?
No, sir, I'm sorry.
Have you guys been doing this in your study groups?
We didn't do it the last time.
You had a study group?
Yes, sir.
Okay. All right, let me share my screen. I'll move into what we have for tonight. So I'm going to share my screen. Let me know when you see my whiteboard.
Hi, good evening, Lee and Kabir.
Good evening, Kabiru, and welcome. How are you doing today?
Good, how are you, sir?
Oh, great.
See by then. Now, at least going to the movies, that'll be economical. One child, 2 seniors, thanks. It's not a lot of spending.
All right. Let me see. What are we having here? All right, so let's talk about what we got for today. So last week we were talking about repository, and let's see. And we spoke about building a repository. We said the purpose of a repository is so that we can have packages. We can have a centralized location for packages such that whenever we want to install packages, we can take from that repository. Is that correct?
Yes, sir.
All right, great. Let me see. We said there's something called Red Hat Network or Red Hat Satellite Server, which is owned by the manufacturer or the vendors. And so to make that easy, the vendors, whenever you build a server, a Red Hat server, there's always that option that asks you, do you want to register this server? Can we all remember that?
Yes.
Now, if you take that option and you register that server, that server is automatically connected to the vendor's network. And if you need packages, whenever you do your YUM or RPM, we automatically download from that vendor's repository, which means you don't need to build your own repository. But because that situation requires some level of payment, which is not cheap, we now resolve to building our own local repository such that we can get packages locally from them and without paying any dime. Does that make sense?
Yes, sir. Sir.
Now we said there are two kinds of commands that are involved when it comes to installing packages on a Red Hat system. We said the RPM. What does RPM stands for?
Red Hat Package Management.
Good. And we said, what was the name of the other one?
Yum yum.
Yes, the YUM. What does YUM stands for?
Yellow Dog Update Manager.
Correct, Yellow Update Manager. Now, we also went further and explained the differences between these two. We said, when do we use RPM and when can we use YUM? And let me share my PowerPoint instead. I think that may help us while we review. Can you guys see my PowerPoint?
Yes.
Yes, sir.
All right, let's go. When did we use RPM? When do we use YUM? Just think out of the box, you know. All right, so we said with RPM, the package must be present wherever you want to do the installation. So either you download the package, move it into your system, which we're going to see example, or you have a repository built, but wherever you are standing, when you do a PWD, that package should be standing there with you. And we said with RPM, the packages will always end with .rpm. Is that true?
Yes,
Yes,
sir.
sir.
And with RPM has a limitation whereby you must have the dependencies also installed. Dependencies are packages that are depending on other packages before they're being installed. Some of you run into issues that they're asking for dependencies. Do we have any witness in the house?
Yes, sir.
Yes, sir.
So those are some of the limitations of RPM. The package must be present, and you will need dependencies. So YUM is an advanced tool as compared to RPM. So YUM is advisable to always use YUM. That's why after installation, after building a repository, we start using YUM because we can access those packages even from another server. Does that make sense?
Yes, sir.
Any question up to this point? So you guys are looking at my PowerPoint, is that true?
Yes.
Yeah, so these are some commonly used commands, RPM-QA, and we are saying to check if a specific package is present. So this is how you query to find out whether a package has been installed or not. So this is a package name. So let's say you want to check whether Delta has been installed. You're gonna run RPM-QA space and then the package details, Delta, for example. Does that make sense?
Yes, sir. What does that option stands for? The
Query.
Query. Okay.
Query availability.
Okay.
So you want to see if it is present, if it has been installed already, because there are times they may ask you in an interview, which command will you use to check if a package has been installed or not?
Yes.
Okay. Godfrey, sorry, I just saw a missed call. Were you calling?
Yes, so that was before the call. We were trying to log in and
Oh, okay.
wasn't anyone there.
All right, sorry about that. Yeah, so and then for installation is IVH. We all have used this, correct? And if you want to do an if you want to do an upgrade, is UVH. So the same commands you have, the same samples of query you have over here. You may want to take a snapshot, or you may I'll send this after the notes. Can somebody send me a text so I don't forget?
Okay.
Good. Then we move over to say, okay, let's learn how to build a repository. And we had these steps, which most of you have. Is there anybody here who did not send in the project?
I haven't yet, sir.
Yes,
Oh, okay. Are you working on it?
Yes, sir.
yes,
I am too.
I am too.
Okay. So we had all of these steps clearly defined, and we have practiced them. And let me see where we let me see. All right, correct. So let me share now my white screen. So we say when building a repository, one of the most important things is the base URL, which is the configuration file, which is found within your server. So we say your base URL should always be HTTP, your IP address, slash the location where your repository was created. In this scenario, we can just say online repo. And the document root directory, which is where your repository is, should always be found. This location is permanent. It is compulsory that you create a repository always in this location /var. Excuse my writing. HTML. And then in this example, we are using the word online. Does that make sense? Online repo.
So you can use whatever name you wish to use.
Sure. So that must always match this one.
Okay.
Does that make sense?
Yes.
So remember, we're dealing with
Just
two
the ending,
solutions.
right? We don't need to write the whole absolute path.
Correct, just like you see here. So the IP address replaces the absolute path.
Got it.
And we said this file, which is your configuration file, should always be located in /etc and yum.repos.z, and you can call this http.repo, but it must end with a .repo. Does that make sense?
Yes.
So remember, this file is located in here. We're just giving an example. Miss Pale, is that clear with you?
Yes, sir.
Very good. So if you make an error and this file does not end with this extension, you're gonna see that your repo will not run successfully. When you do yum repo list, you may not see the packages. Because what happens is that when you are installing on this system, let's say this is server 1, and you run your yum over here, install, let's say an example, the package name is nmap. Nmap. What happens is that this instruction goes into this location to look for this file here, because that's the location where the system tells every instruction where your repository is found. Does that make sense?
Yes, sir.
Yes, sir.
So when it gets in here and does not recognize this file with a .repo, it will not be able to see this guy. Remember, imagine if you spell this file and it ends with an S, and say it ends with an S.repos with an S over here. This command over here, young command, is not gonna recognize repos with an S, so it will fail. So you must make sure that it is exactly as the system expected to be spelled. And then when that instruction gets in there now, you are telling your system that our repository is found in HTTP, this IP address, and this location, because that's where we build it over here, correct? That's where the packages are found. Am I clear?
Yeah.
And then now it will pick up the packages that are in here, which you have set up in this repository, and then install it. And then you see your installation going through successful. Does that make sense?
Yes.
Now, tonight, can I clean this? You clean this?
Yes.
Anyway, let me just leave it there. We might still use it.
Sir, I have a question.
Sure, go ahead.
The last example you gave in the last class, the base URL ended with online repository, not repo. So are you saying it has to end with repo, or the one in the yum repos.d has to end with repo?
Who wants to respond to that?
Because
Yeah, we got your question.
I think it's the one that ends with D that has to end with repo. And the other one has to be just exactly whatever you have it in var as.
Perfect. Is that correct? So let's make that point clear. Let's say over here, and just like the question Rama asked, can it have any name? Is that true? So let's call it over here. We're building, and we're gonna call it HTTP underscore online. Yeah, we're gonna make sure that same name that we have given it up there is what reflects over here.
Okay, yes, thank you. That's what I was in doubt of.
However, whatever the scenario we are building, we can give any name over here also, but let's make
But it
sure
has
that it ends with a .repo. So
repo.
we can call this John
Okay,
.repo.
thank you, sir.
Is that clear for everybody?
Yes, sir.
And we said the reason we are doing that is because when we give an instruction, if the system will be looking for what is with .repo, and if you see John without no .repo, it will not be able to get that far.
Yeah,
So if you see a .repos with an S, that's also a misspell. So
Yeah.
it will still not get the instruction.
true.
However, if you see the right thing, it will now get into, which is where you will find the base URL, correct?
Yes, sir.
And then read this location where you are pointing your original repository, which is right here. So imagine if you have HTTP underscore online with an S, and here you're pointing something without the S at the end.
It will fail.
That's another misspell, correct?
Yes, sir.
So that's one of the things Unix is exact. And so you must be able to look through your lines and make sure that they're the same. Are we clear up to this point?
Yes, sir.
Very good. So tonight we're going to learn, because according to what we have done in this repository, installations can only happen within server 1. S1 can right here. Can we all see our S1?
Yes, sir.
Joyce, can you identify S1?
Yes, sir.
Good. So let's have S2 over here so that we can best replicate what we are trying to explain today. So over here we have S2. Now the reason is because imagine we say what's the number of our servers we are managing. What's the number?
250.
So imagine we have 250 servers. Are we gonna be a repository on all 250?
No, sir.
We're gonna be a repository on one, and we're gonna call that one the master. So let's also add that name over here so that we start getting used to master. Does that make sense?
Yes, sir.
And whoever is depending on the master, we're gonna call it the client. Is that clear?
Yes, sir.
So we're gonna call our S2 the client, because we want to make sure that on the other servers that depending on the master, they can all get their packages from that master. And let's not forget to make it known that we said HTTPD must be running over here, correct?
On the master, yes, sir.
HTTPD. Let's make it on. Very important. Are we all following?
Yes, sir.
All right, good. Somebody is not muted. Thank you. So now on the client, we must, how do we set up the client? Now it's important to make sure you understand that communication at this level is over the browser, which means you have to open something like Google. Do we all see Google in our systems when we build them? Or Mozilla? You guys see a browser on your
Where
server, correct?
I never did.
Didn't notice it.
Okay, let me bring up one here. Let me share my screen. You guys see my VirtualBox?
Yes.
Yes.
All right, can you see Mozilla over here?
Yes.
So if we click on these, we can open a browser. Can we see that?
Yeah.
Right, we can, if we open another browser here, we can go to Google. So we can see. Can we see that?
Yes, sir.
We can log into our email, correct?
Right.
Is that clear?
Yes, it is.
Good. So I was just trying to make, because at this level, when we're talking about repository, communications is over the browser. So the only way server one or the master can talk to the client is over the browser. Does some of you have your repository up and running? If you have a repository server, can you spin it up? If you don't have, that's fine. Let's just continue. You should follow up from my screen. So we are saying that for server 2 to communicate with server 1 when it comes to installation of packages, because all what we are doing to server 2 is to make sure that when we run yum install over here, nmap, you should be able to send a communication line over here in server 2 and pick up packages.
Server 1.
Give me a minute. And pick up the packages from here, because that instruction will still come over here and look for this file. Because over here in server 1, the specification we are making is very simple. So the steps to set up a client server in server 2 is thus. So let me share that, and we copy, and then we move forward. Does that make sense?
Yes, sir.
That way you guys can have some questions. So over in server 1, we are doing just 4 steps. Number 1, we are making sure that HTTP is running, which we can start. We all can perform that task. Is that correct?
Yes, sir.
So step number 2, we are making sure that we run check config. What's the advantage of check config command?
To make it persistent across reboot.
Can you break that down for us? That's very high terminology.
So that when we reboot our server, it's still going to run.
Correct. And then thirdly, we are creating this file. Do we all know the location of this file?
Yes, sir.
So on the client, you are also cd to yum.repos.d and create a file which will also end with .repo, exactly the same. And that information in that file is pointing to your master details. Does that make sense?
Please, can you explain again?
Correct. So we are saying that on the client server, remember we are dealing with the client right here. We have left the master, correct?
Yes, sir.
This IP address you see on the client is the IP that belongs to the master.
Okay.
So the base URL here at the level of the client is base URL equals http/ the IP of the master, and the same name that you use when you're creating the master, whatever name your repository location is the same thing you're pointing here at the level of the client, because you're simply telling the client that when you want to install, go and look for the packages over in the master. Does that make sense?
Okay, sir. So we're going to we're going to get into repos.d, then we're going to create another configuration file like we did in the master.
For server 2, correct.
Okay, sir.
Is that clear?
Yes, sir.
I'm asking the whole class.
Kind of.
All right, so repeat. So for server 2, we say start HTTP. Can we run that command?
Yes, sir.
Okay, we say do check config. Check config command HTTP on. And then the third thing we are saying VI into, or let's make it simple, CD2, this location, etc, yum.repos.d, and create a .repo file, which you can call any name, but let it end with the .repo. Does that make sense?
Yes, sir.
Is that getting better?
Yes.
Remember that file end with a .repo. Let me make it clearer. Remember, we are dealing with server 2. And in this server 2, all the details in that your repo file is pointing to the details that you have in your master right here. Does that make sense?
That one CD into its yum.
Yeah, bitrate, your volume is low. Can you repeat?
I was asking the third line, is that CD into its yum?
Yes, CD into yum.repos.d and via into online.repo, whatever name you want to give it over there, but it should end with the .repo. Does that make sense?
Yes.
And all the details after your VI should be pointing directly to what you have here over in the master. Is that clear? Now, so one very important thing is the fact that HTTP must be running, because communication at this level is going through HTTPD. What does HTTPD stands for? Hypertext Transport Protocol. What does D stands for?
Demon.
All right, good. And this run on ports 80. Are you guys writing that down? Mary, any question?
No.
So with this in mind, if you are running any command on the client, you are saying, let the client get every package. So if we are here now and we are running a yum install nmap, what will simply happen is that this instruction will leave the client and go to the master, because not really, let me use this. What will happen is that this instruction, we go to the Etsy repo file, because we said that's where the repository file is located, correct? Now in this Etsy repo file, the details that this instruction will meet are the details that is pointing to this guy. So from here now, it will leave, because that IP address is coming to this master client, and this way you're gonna pick its sorry, it's gonna be over here. And this way it's gonna pick its packages, because your base URL is pointing to this location. Does that make sense? So if we have 250 server, all what we need to do is to create the same scenario for all the clients, S3, S4. You just come to the client and you create a yum.repo file, and you point them, everybody, to the master, and that's where everybody picks up the packages. Is that clear up to this moment?
So this is this is what we will have to do 250 times, right?
Perfect.
Okay.
Remember, we are doing the client because we already have one master. Correct?
Yeah, and have all of them pointing back to the master to pick up the information from there.
Perfect. Is that understood by everyone?
Yes, sir.
All right, good. So let's get into some practicality. So let me share my screen, and we look through some systems. Let's see, what is this? All right, can you guys see my virtual box, my server?
No.
All right, let me share again. You should be able to see it now. So we do a yum repo list. We can see our packages, correct?
Yes.
So we see the host name there is Ironman. So if we take the IP address, which is what we're going one step further. What's the IP address for this server? Who can give me?
Is it 192.168 192.168.1.45?
All right, good. So if you let me see, if you bring this up to your system, let me see what happened here. I think I destroyed this one. Let me bring up another system so we can see that example there. Repo master. Okay, let me bring this up. Please, if you have any question, do not hesitate to interrupt and ask a question so we can get perfect clarification. Let me share my screen. Can you guys see my screen?
Yes, sir.
Yes.
So
Yes, sir.
I'm logging in. Okay. I don't know what's happening with my mouse. Just keep disappearing in here. Anyway, let me look for another method to log in. Let me see. Maybe I didn't configure my mouse to be able to go across different platform. Let me check that out. All right, make it multi-touch. Hope that helps me. Rama, you had a situation you said your repository keeps booting. Did you fix that with the example, with the direction I gave?
Yes, sir.
So what did you do? Did anyone experience a scenario whereby after you upload your ISO and you boot up your server and it keeps taking you for a fresh installation?
Yes,
Yeah,
sir.
Yes, I did.
Yes, sir.
I did.
How did you fix that?
I thought you put the response in the chart. That's where I seen it.
All right, good. That's how you resolve it. Perfect. All right, so if we do Yum repo list here.
We don't send the screen.
Oh, okay. There's no package here also. Can you see now?
Yes, sir.
So Yum repo list, there's no package here. So let's quickly build a repository here. So I'm gonna power off this system, upload my ISO, just like the steps stipulate, and then we move from there. Let me share my screen so you guys follow. Does that make sense?
Yes,
sir.
this will be a good refresher too.
All right, good. So let's go. So we're using the repo master server, power off. Can we see that?
Yes, sir.
So how do we call this process? Whereby the system needs to be off before you can.
Code swap.
Code
Swapping.
What's the opposite of code swapping?
Hot.
Hot swapping.
Hot swap.
All right, good. So if you see my repository here, you see the 6.5, correct?
Yes, sir.
But we're going to build our master. That's why I'm going to send you guys an ISO image, which is a 6.10, so that the repository is going to have advanced packages, updated packages. Does that make sense?
Yes, sir.
Yes, sir.
So let me look for that. I'll go to my Dix because it's not yet there. So can you guys see that 6.10 here?
Yes, sir.
Yes, sir.
So that's what I'm using to build the repository. Remember, the system is running on a 6.5, but the repository is having advanced packages ISO because that's the ISO with the updated package that the whole environment will be using. Are we clear up to that point?
Yes, sir.
Anyway, let me log in and I'll show you guys what I'm referring to. So please pay perfect attention. This is an advanced skill. So we see the system is actually trying to reboot just like what we just explained. So in order for you to fix this, what is happening, the system is picking up the new ISO image. That's why you can even see 6.10 above here. Can we all see that?
No.
Okay, I think I'm not showing that screen that populates. It's not showing up. So you come back in here and you go to systems and you see the boot order. It's telling you that check to floppy, optical, and then hard drive. And remember our ISO image was picked over here, which is optical. Can you see that? The disks. So that's where it's saying the optical. So if you uncheck this, floppy does not exist. So whether it's checked or unchecked, it will not show up anything. Does that make sense?
Yes, sir.
Yes, sir.
So if we uncheck optical, which is what it's saying, we are telling the system that pick up from hard drive, which is where we have our installation running already. Does that make sense?
Yes.
Yes, sir.
So we click OK and we go back there. Who did not understand what we just did? All right, so let's run this refresher, just like how our calls it, and then we get to board. So let me log in. That's root.
Sir,
Yes.
your console is a little, the way I see it, I don't know if that's how everybody sees it.
It's
That's
too
the same
small.
problem we had on Friday. When
We only see the previous
installed.
screen.
So
So
we
you-
did see your.
you just share again.
Box. Okay, now we see it. Thank you.
Yes, I just had to share the other window again. So you can see that our ISO is a 6.10, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
So we log into this system. Now, how do I check the version of this operating system which I'm running? We say cat etc Red Hat release. Use your tab key. I see a lot of you don't use your tab key. That's one of the advantages of a bash script. So if we cat etc Red Hat release, you see that we are running on a 6.5, correct?
Yes, sir.
But the ISO we are going to build is a 6.10, the repository. Make sense?
Sure.
Good. So GF-H, we have our repository loaded, and now we want to, next step is for us to copy it into the location where we'll mount it to the temporal mount point. Is that correct?
Yes, sir.
So do mount /def/s0 into
Sir,
slash
is there
MNT.
a reason why we're not why the repository has to be 6.10 if we're using 6.5 Red Hat release?
Okay, remember the reason for a repository is to have the advanced updated packages. So because
Okay.
6.10 is update as compared to 6.5, correct?
Right, so always have to be a step above.
The reason we are using 6.10 is because at the end of this class we're gonna do patching. Patching simply means updating, just like once a month our phone do receive updates, correct? So your provider is sending an updated package and saying for security reasons. But last week, remember, we did not use 6.10. We use 6.5 because we just want to make our packages available. So I could still use 6.5, but because I want to address patching as a topic tonight, I said, let me use 6.10 so that we'll have an update package system so that when we patch this server is not going to be 6.5 again. It's going to move to 6.10.
Got you.
Does that make sense? That's a good question.
Yes, sir.
So we are using one stone to shoot two birds in the sense that we are learning how to be a repository, but we are not just using regular ISO image. We're using that which is a advanced, which is a 6.10. Is that clear?
In a job setting, is this most likely what you'll be asked to do, or?
Yes, in a job setting, remember you need to get the most updated package online
Mhm,
and then build a master repository and then point everybody to the master.
mhm. So let's say if there's a new ISO image that came out and the master repository that you made before, let's say it's 6.5, then you have to remake that repository?
Correct, yes.
Okay.
Is that clear with everyone? Joyce,
Yes,
is
sir.
that clear?
Yes, sir.
All right, so we mount, so we hit enter. So if we do df-h just to check, we see that we have mount, and let's move further by making a directory, which is /var World Wide Web HTML. So which name should we, let's use online repo tonight. So online, let's do online underscore repo. I'm trying to do a naming convention that would not confuse you guys. So let's do HTTP repo. No, let me see. Let's do on HTTP repos with an S. This is the location where we're going to create our repository. Is that clear?
Yes, sir.
All right, we hit enter. And then we copy our packages. We say the command is AVR, or is it AVR or AVH?
AVR.
Yeah.
AVR. Our packages are located in MNT, package with a P, uppercase P,
Mhm.
That was
and then a star
Good.
to make sure we are saying everything. And we're copying those packages into /var. I'm using my tab key to spell so that I know that I am on point. Is that clear?
Yes, sir.
All right, we hit enter. Okay. All right, good. So that is done. So we CD to that location so that we can see our packages, HTML and HTTP. So if we list, we see that our packages are there. Next step is for us to be able to install our 3 required packages. That is done through RPM. Is it IVH?
IVH, yeah.
And the first package is Delta. So if we use the auto tap key, it will auto spell for you. Is that correct?
Yes,
So
sir.
it doesn't work for me.
It depends how you're doing it. So for you to use the auto tap, you type RPM, IVH, and so you start by typing the first 2 letters of the package. So you say, in this scenario, Python. And then you touch your tab key now. You see, it gives me the different available packages that I want to install. If I continue typing and then the tab key will to spell it. Is that how you do it?
Yes, sir.
It still doesn't work for you?
Yes, sir.
So how did you succeed?
I didn't succeed. I even used the star, but it didn't work too.
So who did you reach out to?
And no one.
That solved the issue?
Sorry?
That solved the issue?
No, sir.
So what do you mean by you didn't reach out no one and the issue is not solved? If we did not do package now, how you wouldn't have asked that question, right?
I was gonna ask the question, sir.
But you don't have to wait to come to class to ask that question. Is that correct?
Yes, sir.
So we install the second package, and if we do RPM, what's the name of the third package we are looking for to install?
Great
Create
repo.
So when you touch your tab key, it will spell that for you, and we run create repo. The next thing is for you to run the create repo command, which is responsible for creating the repo. And we're doing -v, just verbose, so that we can see where that command is running. Does that make sense?
Yes, sir.
And the dot is telling you that we are running in this location.
Yeah.
And so we hit enter. Good. So that says complete. Is that clear? The next step is to VI into etc.yum.
After we need to CD into.
So who can explain that? Who can explain why we need to CD or we need to VI? Sandrine.
CD. Oh,
Sandrine,
okay.
over to you.
Why we need to see it in the directory?
No, I'm VI. Can you see my command? I'm VI directly to a file, and Helen is asking that she thought we need to CD. Can you see the command I have on screen?
Yes, I can see it.
All right. So the question is, why don't we
Oh,
CD?
I see. Okay.
Helen, are you clear?
Yes, sir, I am.
Okay. Can you explain to us why don't we CD?
We're not going to CD because we already we going into the etc.yum.repos.d and we're creating that file there. That's what that command is.
So VI is going to create the file and put us into a VI mode directly. Make sense?
Yes, sir.
Is that correct, Sandrine? Perfect. I see a thumbs up. Good. All right. So that's why we don't see this. So when you get advanced, you skip some steps. Some steps I'm doing them for clarity purposes. Make sense? So iPhone 4, are you clear with this point? And Patience, are you clear with this point?
Yes.
Good. So we hit enter. So we are now in that file, and we're creating our file. So we're gonna call this. We said you can give it any name, correct? This is where we said any name. So we're gonna call it online repo. We say name. This you have to maintain. We call it online repository. Most important thing is a base URL. Did we get the IP for this server? HTTPD. So let me check my IP address for this server. So I'll open another terminal and I do IP-A-S. So we are dealing with the 240, correct? Is that clear?
Yes, sir.
Yes.
All right, so I'll go back over here. 192.168.1.240. And who can remember the name we gave to our repository location? If you don't remember, there's no issue, there's no problem going back to check so that you can be exact. Make sense?
Yes, sir, I was locked out, so I'm kind of lost.
So HTTP repos with an S. Yes, Helen. Was that Helen?
You just gave me a new name.
I'm trying to remember. The name I know is different from what you log in. You see how you guys confuse us.
My name is Ebude.
Ebude. Ebude. So we are creating a configuration file, and we just went back to make sure we verify the name of that file where our repo was created.
I thought your IP was 240.
Correct. Yes, 240. See, the whole class is just quiet for you to come back. You guys don't even know what I'm planning for you. You guys just maintain that quietness. You get to me this weekend. Some of you will have bad Christmas.
Oh no,
Oh,
sir.
we're begging, we're
Have
begging.
mercy on us.
How can we started this class and I asked people to do a answer equation and nobody was ready? You guys are adults. You guys are paying money for this. I should come babysit you guys to read. No, I won't do that. So we now know that this allocation is correct. Am I right?
Sir, but I'm lost. Like I said, I was logged out. So why are we using this? This is the client server, right?
No. We are building the master. We started with the master.
Oh,
We
we're
have not
building a
even
new
moved.
master. Okay, sir. Thank you.
Wait. So all that question you're asking was
I'm sorry, sir.
for the client, we don't need to upload an ISO image. Am I correct?
That's why I was confused because I thought the master was 35.35.
Who else is confused at this moment? Let's take a break and bring up everybody.
I'm so sorry.
Are we all together? So if you're not using your mic, you should be chatting.
Yes, sir.
Yes, sir.
What does Miss Ebude means by 35? Oh, sorry, I'm lost. That question.
Come answer that question. I don't know where you come with it. Well, she was thinking.
I thought the master server that we used before was .35, 192.168.1.35. Maybe I'm wrong.
No, we are building a new master, which is 240 now.
Okay, sir. Yes, sir. Now I got it. I'm sorry.
So 35 should not show up anywhere. Okay.
Yes, sir.
So does everybody understand? And Primate, do you understand we are building the master server, the master repository?
Yes,
Hello.
sir.
All right, good. So we move to the next line, which is enabled, and we say 1. And the next line, which is GPG check. Some of you will not like this Christmas season. Let me save this file.
Sir, have mercy on us in Jesus' name.
Except we'll come back to those questions at the end. Is it a deal? All right, so we now run our yum clean all. The purpose of this yum clean all is because we are clearing our database cache.
Yes, yeah.
To make sure that everything is set up. Then we do a yum repo list. All right, good. So it tells you that there's no package, which is 0. As I've always said, our error message will always help us point to what is the issue. So they started by talking about the registration, which we know that we do not want to register, correct?
Yes, sir.
So we are using the backdoor. So it tells you that HTTPD, they cannot reach this server. And remember, we are saying communication is through which protocol? Which service should be up and running?
HTTPD.
HTTPD.
Perfect. So that's what this error message is telling you, that could not connect to host, could not connect. And we say connection is always true. HTTPD. So if we check our service, HTTPD status,
HTTPD, yeah.
it says stop. So
Yeah.
let's start that. And we can check the status again. It says running. Now, if we run our Yum repo list, we can see our packages. Is that clear?
Yes, sir. That is perfect.
So now we are going to set up the client because the objective is so that all our clients should point to the master. Is that correct?
Correct.
So let me see if I can bring up any of these guys here and use them for client. So that we don't need to build a system from scratch. Let's start with Web02. Does that make sense?
Yes, sir.
Godfred, are you with us?
Yes, sir. I'm right here. Good.
Good. Any questions?
No, not from me, sir.
All right, great. So we are having a class on the 26th.
Oh my goodness.
So let me log this in.
So I don't know if you're sharing your screen right now, but you still see the old one.
Oh yes, let me share. I'm still looking for a server that we'll use for client, but let me share so that you guys follow why I go around. Okay. This should already have a repository running because I see an ISO image loaded there. So we cannot use this. You guys think we should build a fresh client?
We could.
That's possible. It don't take long.
Okay, let's do that. Let me share my screen. That will help me explain another concept, which I'm thinking about. Let me share my screen once. So whatever I switch to, you guys will be able to see it. So you guys can see the beta box?
Yes, sir.
All right, let me power down every other server so that we have just what we needed. We need up and running. Let me close all the servers that are hanging out here. All right, that's our master. Okay, so let's build a new client. Make sense? So we're gonna call this repo client and Linux, and we put this on a 64-bit. Can you guys see my screen?
Yes.
All right, good. So we'll push up our memory so that we should have a successful package installation. Remember, most of the time, if your installation stop halfway, is lack of resources. When we talk about resources in this business, what are we referring to?
Space.
Network,
I can't hear you.
CPRO, network,
disk, space.
memory.
All right, good. So I'm pushing my disk space to 105. Can you guys see that?
Yes, sir.
All right, we say create. So we go to our repo client and we'll pick up our ISO. Now remember, we want to be our client with a 6.5 so that when we patch it with a 6.8, with a 6.10, it's gonna go to upgrade. Make sense?
Yes, sir.
Yes.
All right, good. Let's also make our mouse multi-touch and also network. Somebody is not muted. All right, good. 6.5. Perfect. All right. So let me bring the screen over here. Can you guys see the installation process?
Yes, sir.
All right, good. So we skip. All right, say okay. So it's a good thing we are building fresh systems so that everybody will understand where we are coming from and where we are going into. You see the concepts clear. We know host name, we can call this our client repo. Make sense?
Yes, sir.
And we're gonna do this so that we can move faster.
Spelling.
I can't hear you.
I think something wrong with the spelling.
Oh, okay. Thank you. We say next. Enter our root password. So we're gonna do customize so that I can explain another concept here. So we say next. Now, remember we have said you must be able to build a system that should be able to go through a successful audit. Does that make sense?
Yes.
Now, that's not all the time scenario, which means there are times at work your team can just ask you to build a server that you guys can be using to play around. You know, that must not now look like a server that must go through audit, which means it must not have all the /var audit log /term bet the one a specific directory to have all the space, maybe /var. Does that make sense?
Yes, sir.
So in that scenario, it's good to find out what's the purpose of this server that I will be building. How do you guys want me to partition it? Should it have various partition systems so that it's more secure, or there's some specific part? So it's good to always ask some of those questions. Are we clear up to that point?
Yes, sir.
So in this scenario, we are building this is the kind of example for this scenario. We are building this server, but we are not putting all the partitions because this server is not going to be on it's not the server that auditors will be looking at. Are we clear with this example?
Yes, sir.
All right, so we say okay. So we create /var because now, so with this example, I'm just choosing some mount point which I think will be required for this build, and I'm setting them up. So let's do, what's our remainder free? 57. Okay, so we can do 35 here. Okay. Looking at this partition style, any question in regards to what I just explained? This is to let you know that it must not always be /home /var /term like we talk about. There are situations whereby your team just want a simple server that you guys can play around with. Does that make sense?
So,
All right,
Yes,
so
sir.
we say next. If you like, you guys answer, we are moving. So installation is running, and so that we can have our client server set up. We are not setting up root pass this for now. So another important factor, we are choosing desktop. And now that we know about packages, it says, please select any additional repository that you want to use for software installation. There are times they'll tell you that this server will be used for high availability. If you select these packages, this extra package will be installed. If you select load balancer, extra package for load balancer will be extracted from your ISO image and installed. So it all depends on what kind of server are you building. With that response from your team, you can now select the extra packages that it may be required from this at this state of this installation. Can we see that?
Yes,
Yes, sir.
sir.
Yes, sir.
So we just selected 2 extra. Let me leave it for high availability. So we say next. All right. Did you notice that our package number has changed?
Yes, sir.
Because of that extra package we select for high availability. If we select load balancing, the number will get bigger because we are selecting extra packages we want to be installed on this server. Does that make sense?
Yes, sir.
So that's the purpose of that part that says repository packages. Any question?
Yes, sir.
Go ahead, Goffin.
Yeah, I was just going to ask, since we've selected a few, could we just discuss about the, differences, like for those ones that we've picked up, high availability, scalability, and all those things?
Oh, no, we'll discuss that subsequently.
Oh, okay.
Yeah, high availability and scalability. Yes, we'll handle that, especially during cloud computing. So while this installation is running, I want us to get back to the master. Our master server is here. Is that true?
Yes, sir.
Yes, sir.
Let's make sure it says master. What name did we give this master server? Repo server, correct?
Mhm.
So what's the IP? Remember we said you should be able to have your IP 24 on the browser. So let's go back to the browser and enter our IP address 192.168.1.24. Was it 245 or 240?
240.
240.
Oh, 240. All right, good. So you see is that it tells you that we have set up an Apache server, which is what is pointing to our IP address. Now, remember, in our base URL, we said it should be what was the location for our repository? HTTPD repos with an S. Is that correct?
Yes, sir.
And we hit enter. Can you see our packages?
Yes, sir.
Yeah.
Now that is telling you that you can communicate. That server is now open. You can communicate with other servers and provide them access to these packages. This is on the server section. Is that true?
Yes, sir.
If I come to my desktop now, this is my laptop, and I enter this IP address, and this is what you guys all are gonna do, which is a 240.192.168.1.240. That should be able to open. Let me see. .192.168.1.240. Okay, 240, correct. That cannot be reached. Let's say if we do HTTP repos with an S, same thing. I think I need to reboot my system to get through that. Installation is going through. So what am I saying by this? This is a test to let you know that your repository can be accessed over the browser. Those packages you have built can be accessed. So moving forward, when you build your repository, you need to pick up the IP address and open up a browser, just like what we just did here, and test the IP address itself first without your location for your repository. And if you read through this, it will tell you that this is a sample web server to show you that your Apache application is running. Does that make sense? However, if you include the path for your repository, you should be able to see your packages also. So it is on this same route that our client server will be contacting this master server in order to pick up these packages for installation. Does that make sense?
Yes, sir.
All right, installation is still running. I was just making sure. So any question? No question. So when we get to when our installation is complete, we just gonna complete setup, and then we can now build our client server. So we can take a 5 minutes break so that we make use of this time while waiting. So please indicate if you are going for break so we can check out with you when you return. All right, installation is complete. We are proceeding. Those who step out for break, are they back? All right, nothing intricate here. We're just doing regular boot up as per we all know, and we'll check again before we start the client process. All right, so we're moving forward with this. Yes, we agree. Prepare to register later. Register later. Not at this moment. And finish. Any concerns, yeah, up to this point?
No, sir. Not right now.
All right, good. Is anybody out for break? Ebude, are you there? Ebude, are you back?
I'm back, sir. Thank you.
Just making sure everybody is present before we proceed. So are we good to go?
Yes, sir.
All right, so we are logging into the client. We already have the master running and we have checked. And so we are logging into the client. And if we do a YUM repo list here, we don't see anything because we have not set this up yet. Is that correct?
Yes, sir.
So if we try to install a package also, for example, Nmap, this installation also fails. It says no package available, nothing to do. Can we all see that?
Yes, sir.
So
Yes,
who can guide us with the steps to create a client, which we have copied? What's the first thing to do at this client section? Look at your notes and tell me what's the first thing to do at the client.
That be the start HTTPD.
All right, so we say service HTTPD status. Let's check. So it says stop. So let's start. All right, that is start. What's the next step?
Check config HTTPD on.
Config HTTPD on.
Getting back to work,
HTTPS.
Oh, sorry. Thank you. So that's why I even said none of that exists. All right, good. Next.
You CD, it's no, sorry, configure.
Yes. What are we configuring?
It's etc/yum.repos.d.
So we are saying we set up the configuration file for the repository, right?
Okay.
yum.repos.d, and we can call this client.repo. Does that make sense?
Yes, sir.
We hit enter. So the same scenario goes in. We can call this online repo. Any naming convention will be fine. What's the name? We can call it online repo because remember all its repositories will be coming from the master. Is that true?
Yes, sir.
Base
Sir, just for clarification, the
Yes.
online repo, does it have to be in uppercase or lowercase? Because we had this discussion in our Friday group. Will there be a change?
Remember we said majority of the things in Linux are in lower cases. So to be on the safe side, always stay within lowercase in everything you do within Linux if you have a doubt.
Okay, sir.
Is that clear?
Yes, sir.
So who wants to give me the details of this URL? Eta, do you want to go? HTTP. Yes, what next? Eta, go ahead. You can either explain or you give me the details, at least one of any of the two. Why are you muted? No, you shouldn't be on mute. You're the one talking.
So I think we'll put the IP address
of
the base URL.
The IP address of the base URL. We are on the base URL. Which IP address are we putting?
The one on this client server.
No.
The master
Okay.
server.
Was that the IP?
Yes, sir.
All
Yes,
right,
sir.
what follows?
Um, um, mm,
Who wants to help?
Can I?
Go ahead.
The name of the repo.
Which is HTTP repos with an S. Is that true?
Yes, sir.
If you have a doubt, it's simple. You just go back to your master and go take a look. It won't cost you anything. Is that true?
Yes, sir.
So we are at our master. If we do PWD, you see where we are located?
Yes, sir.
So what's the name?
HTTP repos.
Perfect. So avoid headache. Just go check it and get the right thing here. Does that make sense?
Yes, sir.
So we go to the next line. We said enabled equals 1. GPG check equals 0. Are we done?
Yes, sir. Save and quit.
Okay, good. So you do your yum clean all, same thing. And then yum repolice. All right, good. So we see that it gives us an error. And does it look familiar?
Yes, sir.
That tells us that what?
We need to check service.
Perfect. So we said service HTTPD status. But if that is running,
Running.
okay. All right, so we do yum repo list again. All right, good. So if we let's look through the requirement of setting up the client server. Did we read everything that is needed over there on the master? On the master, did we state that port 80 needs to be open?
Oh, yeah.
Are we all following? Can you see my screen?
Yes.
Yes, sir.
So on the master, we have set up this one, correct?
Yes, sir.
We start, but we were missing port 80. Is that true?
Yes.
So let's get to the master and make sure that that port is
What
open.
is open? Yes.
So this seems to be our master server. Let us check what's name. So to open that port, you go to systems. So we are going to firewall administration. Please, everybody should write that down. I'm going to start again. To open the port on a server, you go to systems, administration, and then firewall. Rama, are you up to this level? Rama, are you there? So we click enter and we close this window. So these are various ports down this system. And if you scroll down, you can read through these various names. We're going to learn all of them. Can you see SSH? What does SSH do?
Secure sharing.
What do we use SSH for?
So move from one server to another.
Perfect. It tells you that it is checked, which means it's open, correct?
Yes, sir.
So in this scenario, what are we looking for?
HTTPD.
You see it below and it's not checked, correct?
Yes, sir.
And it tells you the port number 80. So that's what we came to open. So you have to check it and then click apply.
Okay.
And they're asking you, clicking the yes button will override existing firewall configuration. Are you sure you want to do this? We say yes, because we are adding a new rule. Does that make sense?
Yes, sir.
So we say yes. And then you reload. Rama, are you there? All right, let's close this window. Awa, are you clear up to this point?
I am.
Perfect.
Yes, sir.
Good. So we have open port 80. Let's go back to our client because our client was showing us a message and we thought it was service not available, but we check, we see that our service is running. Does that make sense?
Yes, sir.
And so we now went and open port 80 on the client. So let's run again our YAM repo list. Can we see that we can now have packages, correct?
Yes, sir.
And it's telling you that just to prove that the repository that is picking up is not the one where we are standing. If you go to your master, is this a master server? Yes, good. Let's cut the configuration file for our repository. yam.repos. What did we have here? Is it online or HTTP? Okay, online repo. You see, the name is online repo. And what our client is speaking is online repo right here. Can you see that?
Yes, sir.
And we can see packages. So if we want to install anything now, we do yum install nmap. Let's give it a space. It's going to run this installation, picking up packages from the master. Remember, we did not build any repository here on the client. Is that true?
Yes.
So we say yes.
I go.
The same thing will happen if we say, let's check our repository on the level of the browser. Which IP address should we be entering over here? Peter, are you there?
Yes, I'm here.
Which IP address should we be entering over here at the browser? We are dealing with a client.
Which IP address we put with the client?
On the browser, can you see my screen?
Yes.
Yes, which IP address are we want to check to see if we can access the packages over the browser.
It's the 192, the one for the master.
Okay. 240. Perfect. Remember, we are the client, correct?
Yes, sir.
But the client is seeing the master using the IP address of the master because number one, we have HTTPD up and running and we have port 80 open. Any question? Godfrey, any concern?
No, sir, I'm good.
So with these, we can authoritatively say that we have satisfied this requirement with building a master server and a client server, what we just demonstrated here. Maybe we'll do this again afresh. Can you guys see my screen?
Yes, sir.
So we have our environment. We said this is our data center. And we said what's the number of servers we have on this data center?
$250.
Let's say 250. So server 1 and server 2 and server 3, server 4, 5, 6, and 7. We're gonna call this the dev environment. Dev stands for development. This is gonna call this a test. I'm gonna call this a production. So let's say our repository is server 3. So we have configured our repository for this environment to run on server 3. It means every other person is going to be a client pointing to that master. Does that make sense?
Yes, sir.
Yes, sir.
So after building our master, we just need to come run the 3 commands on our client, and any installation we want to do in this environment, everybody will point and get their packages from this guy. Does that make sense?
Yes, sir.
So you should be able to build a repository, build a master repository, and set up a client repository such that all the clients can get their packages from the master. Is that something we think we can perform?
Yes,
Yes,
sir.
sir.
All right, good.
Quick question, sir.
Go ahead.
Yes, sir. Can I be able to, access that space, the one we just created right now from my end here?
No, you can't access this because I did not make it a white IP.
Oh, yeah, because I was just trying to do that right now in the background and
You're trying to hack.
it didn't work.
All right, good. So if you have your repository running, master any of your repositories that you did last week, just take the IP and put in the browser. Even on your phone, you'll see the packages listed. And so what we are saying here, looking at this environment, we said there's a dev, test, and prod environment. We're going to discuss, elaborate about that sometime. Before we had this repository build, so let's assume there's no repository. We have not set up. You are not working in this company yet, and you have been employed now. And all these servers were on subscription, Red Hat subscription, and each cost about $1,000 a month for subscription. If we multiply this by 250, what would be the total cost this company is spending on Red Hat for subscription?
Cool, 250K.
All right, good. Now you came in as an employer, as a system admin, and you look at, because you all will agree with me that anybody who is cutting costs in a company, you are a vital resource. Is that true?
Yes, sir.
You suggest to your company that rather than paying 250K for all the servers, we can configure one server per repository and per environment. These are our master's repository, and point everybody to those repository, and then cancel those subscription. The reason we're gonna left with 3 subscription because we want to use those servers that are on subscription to get the most updated packages from Red Hat. Is that correct?
Yes, sir.
So this is master, and this is master. So instead of paying 250, we're gonna be paying 3,000 for 3 servers for 3 different environments, and then point every server in that environment to their master. So all these guys here will be taking their packages from here. All these guys will be taking their packages from here. And the same thing happens over here. Is that something we have cut down cost?
Sure.
Big time.
Yeah.
So if they ask you, or when you go to an interview, this question will always be asked, can you tell us about a project that you're working, or a project that you feel satisfied? You want to talk about setting up a repository in your current environment to help cut down cost. Does that make sense?
Yes, sir.
So we're going to be elaborating more about that kind of a storyline. For now, let us know how to set up a client, because we all can set up masters. Is that true? That's what we did last week. Set up master servers, correct?
Correct.
So any question?
Not for me. Okay.
All right, good. So let's enter into the other part, which is patching, which is why we did use the 6 point. Okay, so although this repository is running, although they are running, let's still check our version of Red Hat which we are using. So if we do cat etc, Red Hat release. We are still in 6.5, correct?
Right.
Good.
Yeah.
So for us to patch this system, we will need to use packages that are on the repository, which is going to be an upgrade. And when that is successful, this system will not be a 6.5 again. It's going to move to a 6.10. Is that correct?
Yes, sir.
All right. So let me bring up these with regards to patching, so we are moving to a different topic now. You guys need a 5-minute break?
We just got one.
You never know. You guys are sounding like babies, so I can give you 2. All right.
Just
So
need a Christmas break.
how do you patch in your environment? That's the question they're going to ask you in an interview. So we want to discuss patching on its entirety, and then we can move forward. So these are some of the automated tools that are used in patching. You have Ansible, you have Tanium, you have Big Brother.
Oh, wow.
We're going to be doing Ansible. That will be our specialty. So patching policies. I read, patching is one of those monthly. So take note of the fact that I'm saying monthly. It means it doesn't happen all the time, correct?
Yes, sir.
Tasks / procedures which every manager wants to be very careful during the implementation. Now, the reason managers are careful when it comes to patching is because, remember, we are upgrading. You are moving from a 6.5 to a 6.6 or 6.7 or 6.10. The further the number means the more packages you must have missed. So we are running on the 6.5. It means 4 other upgrades are taking place before 6.10. Does that make sense?
Yes, sir.
Because the number simply indicates the next available update. So after 6.10, we expect, what update do we expect to see next?
11.
Is that true?
0.11.
Who agrees with 11?
So what was the question? Sorry, I did not get it here.
We are saying if we are talking about patching as an update procedure, you know, if we are running a 6.5 and then we update a package or a system and it goes to 6.10, it means we have skipped 4 different updates because it's supposed to be chronological: 6.5, 6.6, 6.7, 6.8, 6.10. So if you miss all those updates and you run a 6.10, it's going to update 6.7, 6.8, 6.9 up to 6.10.
Oh, okay.
Does that make sense?
Yes, sir.
So after we are running a 6.10 system, if we're looking for a next update, what version should we expect to have?
1.5.
What do you mean by 1.5?
6.14.
6.11, sir. But
Oh.
but it depends.
I'm thinking since it's gonna we move from
It depends.
6.5,
It can go to 7.
It actually depends, you know, because did they have a small release? Was there a major release? You know, now what kind of release?
It's a major release. So I'll repeat my statement. So
Okay.
we are running on a 6.5 and we're gonna update to a 6.10, and that was successful. What next level of update we are expecting?
It could be 7.
Someone what? We're talking about 6.5, 6.10. So
You are 10, so sometimes it depends. I don't know.
7.0.
6.11, sir.
6.15.
let me bring up a whiteboard. Some things are not clicking. So let me share this white screen.
Then if you move from 6.5 to 10 and everything else is upgraded in between.
All right, so we are saying we have this server. So this server is currently running on a 6.5, correct?
Yes, sir.
We run a patch, we run an update, we patch the system. It now moved to 6.10. And we
Mhm.
are saying that patching simply means updating. So we are going higher in every level. Is that correct?
Yes, sir.
So we are now, and we say these updates come from the vendor. So Red Hat is right here. Red Hat is the one that provided us with this 6.10. And we just read a statement that says patching is monthly. Is that true?
Yes, sir.
Let me share my screen such a way that when I switch, you guys should be able to see all my switches. So if I bring my PowerPoint, it says here patching is a monthly thing, correct?
Sir, yes, sir.
So we have done this patching for October. No, let's take this December. So we have done patching December. If we get to January, what should we expect Red Hat to provide us with? What version of an update?
6.10.
Hannah says 6.10. Is that correct? Who else? What version do we expect to come for January?
6.15.
6.15. How did you get 1.5? Oh, was that NS?
Yes, sir.
Tell us, how did you get 1.5?
Since the old one is 6.5, I think maybe it's adding each step is adding by 0.5, so I added 0.5.
There's no 0.5 here, it's 6.5. This is 15.
No, I mean the old one, the 6.5. I think maybe it's adding by 0.5 to get up to 0.10, 6.10. So I
we
added
add
0.5 to
0.5 here.
I added 0.5 to 0.10.
That will give us 10.5, if that was your analogy, right?
Oh yes, that's what I wanted to say. 10.5.
No, but I understand where you're coming from. Although we left from 6.5 to 6.10, that's because this system has not been patched monthly regularly, because it's supposed to go from 5 to 6 to 7 to 8 to 9 and then finally to 10. But because this system has missed all these patches, when we run 10 will automatically bring in all of these guys. So this system becomes very much updated by accepting 10. Does that make sense?
Yes, sir.
But my question is, all of this happened for December. Now we are moving to January. What do we expect the vendor to provide us?
6.11, sir.
6.11.
So how did it click now? What did you guys think about what made the difference?
Because of the explanation you just gave, sir, it made sense.
So that's what we've been saying all along.
It didn't
Thank
click
you.
at that point.
Thank you, Godfrey. So you just tell me that you guys like visual.
Yes, sir. That's how I learned.
I'm
a visual learner.
What were they drawing in nursing school?
In nursing school, I did YouTube.
Okay, so if we did this in January and we said patching is monthly, we're expecting February. What do you think should come up for February?
6.12.
All right, 6.12. Very simple analogy. Remember, as you rightly asked, was it a full release or a partial release? For now, we're dealing with full releases.
Okay.
Does that make sense? Okay, now let's say you get to work and you log to a system, and you log to a system and you realize you can't, it's a Red Hat release. You see that system is running on a 6.12, correct, right here, 6.12. And you check online, you see that the vendor has a release which is 6.18. What interpretation can you give between these two discrepancies?
That the system has not been patched for 6 months.
You are very close. You are very correct, actually. It tells you that they have missed 6 updates because it is monthly release that these vendors are bringing up. So what I'm trying to point out to you guys is to be able to interpret systems when you see the output for what is showing when it comes to patching. Does that make sense?
Yes, sir.
Did everybody understand Helen? Was it Helen Ebude? Why am I calling you Helen? Have you ever answered Helen?
Hey, you just gave me a new name. That means you'll give us Christmas break.
that will not work. Anyway, let's get back to my PowerPoint. So patching, yes, good. So we said it is a monthly procedure, and every manager is very careful. This word is very important, being careful when it comes to patching, because patching can either fix a system or it can break the system. Break means that after you apply these packages that are coming in can do anything. They can stop SSH from running. They can stop HTTPD. It is upgrading the system. So it's changing everything from 6.5 to 6.10. So it can either fix or break. So this is a very delicate activity. And imagine you performing this on the whole system. You see why they're paying you 6-figure, right? Because there are things that the whole company is depending on you to perform. No other person, any of your IT team members, from database to, well, database, they have their own databases that they patch, from cybersecurity analyst, your project manager, even the president of the company has no idea on what is happening with patching. They can only explain the theory because that's what they read on textbooks. Make sense? But everything is in your hands to patch that system, bring it down and bring it back up, and let every application be running as expected. Does that make sense?
Makes sense. Yeah.
So the importance of this statement, careful, is because it can, imagine Facebook patching their servers, and by the time we wake up in the morning, everybody, oh, you guys remember there was a time this year Facebook was offline for like 5 minutes.
Yes, sir.
Can you guys recall the tension it caused?
Oh, a lot. And
this same year, WhatsApp was down for some few seconds.
Facebook
true.
So that's the kind of risk we bear when we perform a patch session, because anything can happen. Some of you will try logging to your bank accounts and they'll tell you that the system is down for maintenance. Have you ever read that?
Yes, sir.
Yes, sir.
Okay, that means they are patching the servers, they are upgrading them, and that usually happens during the night. And that's why he says you must make sure upper management send an approval, another very important statement, an approval email before you proceeding. So before you patch any system, because of the complexity and the risk involved, you want management to give you a go ahead. Because if it breaks down or it doesn't come back up, it shouldn't be that you made this decision on your own. You should have a proof that I have been given an authorization to perform this task, although it is monthly. So it means every month you should ask for that authorization. Don't assume that they authorized me in October, so in this November, let me just continue. Make sense?
Yeah, very important.
Yes, sir.
The reason is that this is because patching a Linux kernel affects every application running on that server. You must follow a configuration change management plan. Patching can either fix or break communication between applications. Let's copy down this slide and we'll proceed. Any question? All right, no questions.
So, if I may, sir, does this mean that if we have to patch, the system must be down? I mean,
yeah, good question. Now, when you say down, what do you mean?
Yeah, like those. Yeah, because take for example, we have a server that has apps on it. For example, like we said, if we want to patch, basically everything is like on hold, right?
Correct.
And stuff like that. So, so in a way, work is being somehow paused for that time.
Yes.
That's the only way it has to happen. There's no way around that.
All right. So as we said, patching affects every application that's running on your server. So let's say let's use Facebook. Facebook is an application that's running on our servers that we have built. It is good practice to make sure that all the applications are power off before this procedure takes place. So at work, there's usually a guide manual. They will tell you which application run on which server and how to bring it down. When those applications are power off, then now you can run a patch session and then bring back up those applications. Number one of them is database. So the server itself must not be down, because remember, patching deals with the network, correct? We are picking up the packages, if not from the repository, especially if they are the clients need to be connected to the master, which that connection is going over the network. Is that true?
Yes, it is.
So the server itself doesn't need to be down, but the application can be down.
Okay.
Yeah, we're gonna go deeper. We're gonna go deeper with that on the next slide. Are we done? Are we done with this slide? All right, go ahead, Sandra.
Yeah, so in that same line, my question is, all right, I learned in database that there is hot, cold, warm, is it backup? But in this case, in patching, is there something like hot, warm, cold?
Correct. Yes, database are responsible to perform that. For example, just like what I said, patching can break or fix anything. So before we patch every system, we inform everybody, database, application, managers are aware. So everybody can perform a backup of the applications. So that's where you have the word comes, cold backup, warm backup, depending on the amount of data that is being backed up. You also have what we call full backup, cumulative backup. So when we do backup and recovery, we explain all those terms. But the simple concern here is that everybody wants to make sure that they have a backup. In case this system does not come back up or it fails, they can go back to their backup and recover. Does that make sense?
Yes, it does. Thank you.
All right, good. And that brings me to explain a very important procedure. So thank you for that question. Remember when we had the scenario whereby when we added DIX, and you guys include your UUID, some systems could not boot up correctly. Is that true?
Yes.
Yes, sir.
Now, we had made a backup of its FS tab, and we said the reason those systems are not booting up is because the system is checking with its FS tab and realizing that there's an error with whatever UID you have inserted there, and that does not go through. So the way you recover from that is to rename your FSF tab back to the backup copy that you created before you did the activity. Does that make sense?
Yes, sir.
Repeat that, sir, please.
So since your system cannot boot up, we're gonna practice it. I'm just explaining. We understand that the corrupted file should be etcfss tab, because that's the only configuration file we have made and we have just edited before that system breakdown. Is that clear? And before we did that, we created a backup of that file. And we said the reason is in case anything is corrupted, we can revert back to our backup. So whenever you find yourself in that scenario where that system cannot boot, it's just for you to rename your backup with the name of the original file. So if your backup was etc fs tab 02, you can do a move mv etc fs tab 02 etc fs tab. That will be a rename, correct?
Yes, sir.
Yes, sir.
Is that clear, Joyce?
Yes, sir.
Well, but we're gonna perform it. I was just explaining. Are we done with this slide?
I have another question.
Okay, go ahead.
In that line of explanation that you're giving, in my case, it failed. So it did not boot to normal screen. I found myself in a emergency mode. I didn't know how to get out of this. So I didn't even have the opportunity to rename the backup file. What do I do in that kind of scenario?
Perfect question. And that's why I stopped my explanation, because I didn't want to go deeper since we are on patching now. So can you bring this question when we get to that example?
Sure.
Thank you. Are we done with this slide?
Yes.
All right, so let's move to the next slide. Now, if your classmate asks a question and you don't even understand, you don't have the answer to begin with, and you did not understand the question, that's a bad state. So is anybody falling on that category? We are here to help. All right. Always make sure you start patching with the dev environment. Now, this is very important. We had a, was this slide? Let me see. Okay, good. Can you guys see my whiteboard?
Yes, sir.
So we discussed about environment a little bit last time. Can anybody remember what we said? We said there are three environment: development. Dev stands for development. Can everybody write that down? Test is called test, or some environment, some people call it QA, which stands for qualitative analysis. And then production, or prod, short form for production can be prod. So this is how our data centers are organized. Out of these 250 servers, we can decide that 30 will be under the dev environment. So let's give the dev environment, let's say 30 of these numbers. That's 30 number of servers. Now, the dev environment is like a playground. It's very important. This is where everybody has access. So let's run some characteristics. So let's make this clear again. This is dev, this is test, and this is prod. So for dev characteristic, we say for everybody or everyone. So it means we can give access to everybody, whether you are a cleaner or you are a secretary, treasurer, anybody who says, create me a user. Can I have a username, password? We can provide that for anybody in this dev environment. We say it's like a playground. This is where developers develop codes. Does that make sense?
Yes, sir.
And then for tests, let's continue with this dev a little bit more. With dev, everybody has read-write access. Now let's get to tests. With tests, all these individuals can still have access, but all that they can do is read only. And for prod, only admins. Does that make sense?
Yes.
Any question? So I'm taking my time to explain this because it's very important. So we said here you have 30 servers, and here we can have 40 servers. And that's put us on 70, and the remainder maybe 130 over here for production. And with these attributes we just explained, if we have only 4 system admins in that company, only the 4 of them we have access over here. And if we have 1,000 employees, everybody can be over here. Now, when developers develop their codes, they must be able to test it to see how it looks like. So it's our responsibilities as system admins. Let's say they are working on server 1, they develop their code over here in server 1. It's our responsibility to move that code for them over to server 1 over here in test environment so that they can test. Now, what usually happens in a work scenario is that after they develop the code, they put in an email or put in a ticket or a request and ask system admins, can you move this code for me? Now, a code is simply a file, just like the files we create using the touch command, but with a content. So when a regular file has a content, it doesn't become it changes the name from a file to a code. So if we do a touch file 01 and it shows 0 content, and after you VI and you put a full stop in file 01 and you save and you quit, you'll refer to file 01 as a code from that moment. So when you get to work and they say, please, can you move that code from, and they give you the absolute path from /tem to file 2/tem, you should understand that the word code, they're just saying move the file. Does that make sense?
Oh, yes.
Any question? So in this scenario, let's say you're at work and you receive an email and the database say, please, can you move this file /home file 2 for me over to the test environment to server 2/home file 2. Is that a task we can perform?
Yes.
Which command are we going to use? Who wants to give us an elaboration? We all know what it takes to do move a file, correct?
Yeah.
Which command comes in mind?
The move, MV.
We are moving from server 1 to server 2.
Oh, SCP. No.
Yes, who wants to speak? You have to be confident. You have to be confident that
Secure copy. You securely copy the file, SCP.
correct. That's the command we're gonna use. Do we all agree?
Yes, sir.
Yes, sir.
So those are the kind of tasks we meet on a day-to-day basis, you know, and we are learning to understand environment such that we can look through and make determinations when we receive requests in terms of providing access. We say dev is cheap, is available for everybody. Test is also available for everybody, but they cannot VI, they cannot write, they cannot execute, they can only read. So a glaring example is like during Halloween or during Christmas. Let's take an example of Facebook. Let's say they want to make sure that when we log in our Facebook pages, we can see some Christmas decorations during Christmas time. Does that make sense?
Yes, sir.
That developers were gonna come over here at dev and make that changes over in their code. But they need to see what they have made, if it looks good the way they expect the clients to see it. Who are the clients? Us, correct?
Yes, sir.
Now they'll place a request for that code to be moved to test so that they can see what they have created in dev. When they see and they say, oh, we are not satisfied, it doesn't, maybe we should add some more flowers. You know, what we just put was 1 flower. We move the code back because they are not satisfied, and for them to make modifications. Reason being that in test, they cannot write. Write is absent here, correct? This is the only where they can read, write, and execute. So there's always this back and forth movement until when they are satisfied before the final product is moved to production. Remember, this is where all the website, the final host is available.
Yes, sir.
So when it comes to Facebook, you and I, this is where we log in because we are the customers. That's why it's important to make sure that all websites are always up in this level, because this is where the customers see production. Those in the office are locked all in this area between dev and test. Does that make sense? Back end.
Yes, sir.
You You sound
I
like
have a question because-
your battery is finishing.
No, I have a question because I learned something in DevOps, similar thing, but they didn't teach us like the admins will be the ones to move the code. They taught us that we can move the code with different commands. So is that something that happens at work? Do DevOps engineers ask the admins to move the codes?
Perfect. DevOps simply means they have now combined a developer and an operating system, which is system admins, to be one person.
Okay.
So instead of the two over here, where we have developer here and admin over here, they have now made you're the one person doing both tasks. Does that make sense?
Okay, sir. Yes, sir.
But that's for you alone. You alone. So if any question, any concern here, we are moving. So this was just for you to understand when you hear because they're going to ask you this question. Can you please explain to us your environment in an interview? They want to find out how many servers you're working with Dynamic Tech. How many servers do you guys have in Dynamic Tech? What are the characteristics of your dev, test, and prod environment? Does everybody just have access to every environment? So you want to always explain to them that our production is very restricted. It is only for admins. That is where we host our website. Our tests only read access is provided to everyone. Our dev is like a playground. Everybody has access. You can do whatever you want to do, but only the production is very, very restricted. When it comes to patching, our dev can be patched during the day. So very important. Let's continue. Let's take out this intruder terminology. So when it comes to patching, dev, so we are explaining patching now when it comes to these environments. So let me write it here, patching. Very important. Dev is during the day, or let's say weekdays. Weekdays. Test, remember test is over here. Same thing, test is also weekdays. Production, always weekends. That's because of the importance of production. Weekend, because nobody is at work, work days is Monday to Friday. Weekend, place is quiet. Nobody is logging to the system. In case anything breaks, we can fix it before Monday. Does that make sense?
Yes, sir.
So when it comes to patching and you're explaining an environment, we'll actually have a write-up so as to put all of this into perspective so that you guys can better understand. You want to explain that in an environment we patch during weekdays for dev and prod, for dev and test, and production is only on weekends. Does that make sense? Now we are running against time. Now remember, that's only the theory. We're explaining the theory when it comes to patching. Let's get to the practical. Are we together?
Yes, sir.
So if we check our host name, we are dealing with a client repo. And if we check our, let's see, Red Hat release, our system is running a 6.5. So let's copy the steps for patching before we implement them. So always make sure you start patching with the dev environment. In case anything faulty, we can make adjustments before getting into the production environment. So when we patch the dev and realize things are breaking, maybe it's affecting HTTP, we can realize this test is breaking a lot of things. We don't even need to bring it into production because we can't afford to have production down. We may even skip that cycle. That's why we are making this explanation here. So we first test the patch on dev and test. If it works well, then production. Some people also call test pre-prod. So the test/pre-prod usually follows the day after the test environment is passed. Reason being that adjustment can be made in case things break down. Production is the most complicated and important environment and is always patched the last. This usually occurs on weekends when traffic is 0. Traffic means when nobody is logging. At the end of a patching process, make sure you send an email to managers, managers with an S, because everybody that has access, and the entire team to make sure that patching is completed. Can we copy this slide? And then we'll move to the commands that are involved to perform a patch system. So copy, make a snapshot, and let me know when you're finished.
Snapshots.
All right, good. Are we done? Okay, I see NS done.
Yes.
All right, so the next slide simply give us the procedure involved in patching. So the first command is just to check the system, because as we said, it's good for you to know the current state of your system. So when you update, you can rest assured, you can put your finger and say, yes, there's been a change. Does that make sense?
Yes, sir.
The second command shall just check to see when last was that system updated. And is this command, the third command that's actually checking also the last, it says check which package will be updated after patching. And this is also to check the package that will be installed during patching. Yum update is the command that updates, that's patch your system, because as you really say updates, that's what's going to update your system. And after every patching session, you must reboot so that you can see the new update can take into effect. Does that make sense?
Yes, sir.
So we're going to patch the client first so that we can rest assured and see that there's an update, because we want to conclude on the hypothesis that all the patches are coming from the master. Does that make sense? Can you guys see my virtual machine by the side?
Yes.
Okay.
So we do uname-A to begin with. So it tells you that the package details is right here. 431 is the last package that the system was updated with on a 6.5. And then if we run RPM -QA, QA stands for what?
Query.
So we are querying the last kernel to see when was the last kernel updated. So let me shift this so we can see that date. Can you see when the last kernel was updated? That was when we last reboot that system. Then yum check update is the third command Remember, all what we are doing, we're not patching the system yet. We're just checking our system. So when we patch it, we can check again and see the changes or the modifications that have been made, correct?
Yes, sir.
Yes, sir.
So you see the amount of packages that are available for updating. So we are asking the system, we're checking the package that which are the packages available for update. This is the list it gave us when we did when we run a Yum update. What does that explanation tells us right there? It says check which packages will be updated. Can you see that? Can you guys see my screen?
Yes, sir.
Yes, sir.
So we can now run our Yum update -y, simply say yes. Remember when we do install and we see the packages, I have to type yes, correct?
Yes, sir.
If you add -y, it will automatically answer that yes for you. You don't need to type yes. So that's the purpose of saying -y over here. So this is the actual command that does the patching. So let's run that now with our client, and we can vehemently say that we are patching our system. So we say Yum update -y. Does that make sense?
Yes, sir.
Yes, sir.
Any question?
So, sir, we can still run Yum updates without the Y, just to answer the question.
Yes, you can still run update. That way you see all the packages that are going to be updated, and then you say yes. And then
Okay.
that will... So we hit enter. So that's installation going through. Our system is being patched. So you see that it's running, it's checking out. We have 702 packages that needs to be installed. Now this is where you need to enter the yes. Since we already entered the Y, we'll just continue. Make sense?
Yes, sir.
Remember, we are patching the client first, because we want the client to pick up the updated packages from the master. So you see packages that are updating, and you see the ones that are being installed. Our target is the kernel. That's the most important package which we are updating. That's what we change it's a release from 6.5 to 6.10. And whenever we are patching the kernel, that's when we say it's a full update. Does that make sense?
Yes, sir.
Yes, sir.
So ask any question. Feel free to ask any question while we are looking through the patching session. So you see we have 1,370 packages to update, and we are still on 170. It is important to make mention then that space is an issue, because remember, you see that the amount of packages we are bringing into this system, correct?
Yes, sir.
If you don't have enough disk space, you will always run into disk fill up 100%. In that scenario, what will you do?
Go and add space.
Add space and continue. Perfect. So you can visualize how your project can look like this Christmas. But you're laughing.
Because I have a lot to deal with.
You guys are very discouraging.
I'm just crying. That laughing is crying.
Can't come to class and ask people to answer questions that we have informed you guys 2 weeks ago, and nobody is ready.
What was that question, sir? Maybe
To walk us through step-by-step approach from when you add a disk until when it's available to use.
To use for repository? Or what? Oh, to add a hard disk. Okay.
Yes, to add a hard disk. And the whole class, nobody was ready.
I didn't get that question. I came late.
Yeah, you came late. Okay, so we are watching our system being patched. So when you hear the word patching, this is all what it entails. This is all what it means. It's just updating that server. And that package is an advanced package, which means after that update, if that server was running on a 6.5, it should go to the next level where that update is taking it to. Does that make sense?
Yes, sir.
Sandrine, are you following? Is Sandrine there? Madam Patience, how are we doing over here?
I'm okay. Thanks.
All right, good. So you can see the kernel installation. The kernel just went through successfully patch number 455. If you look keenly, you see that. Can you see?
Yes, sir.
And it's giving us the details 754. So we're gonna move from was it 431 to a 754 level. Can you see the huge difference from 4 to 7?
Yes, sir.
That's because this system has not been patched for a long time.
Mhm.
Godfrey, any question?
No, sir, I'm good.
Good. How about Joyce?
No, sir.
Sir, I have one.
Go ahead. It's like
So
you have replaced yeah. What's your question?
okay, so every time we want to patch a system, this is now a work scenario. We
Okay.
have to upload the ISO that we want to get to.
Correct.
Okay.
You have to make sure you have the most updated package that you want to use available. Make sense?
Yes, sir.
And you can download that from Red Hat, or you can update it through satellite subscription, just like our scenario where we have 3 servers paying for the subscription. That's so that we can have the most updated package from them and then distribute it to the rest.
Okay.
So we still got a total of 1,370 packages to update in this server. This is how much far back the system was. So if we want to patch using a 6.11, it's going to be 2 minutes because all of these other patches will not be updated. They already have the most up-to-date. So they may just run for some few packages and maybe that will be, does that make sense?
Yes, sir.
The delays we are incurring in this scenario is because of the duration of time that this server has stayed without being patched.
Mhm. So is the duty of a system admin to like patch it monthly, or they just give us?
Yes, it's
Okay.
the duty. Remember, you're the one who built the server. So if any activity that can break that server will be performed by you.
So
Because
if I get to a job and the system has not been patched for the past 6 months, it will be a plus for those who hired me, because I'm trying to patch it for somebody who has not been doing their job.
correct. What's the advantage of patching?
To update packages.
Yes, security wise. Remember, they always say make sure you have the most updated package, just like with our phones. That's why our providers keep pushing the most updated packages so that hackers, it's difficult for them to hack through a system with the most updated packages. They usually find a loophole through system that has not been updated, that's not being updated frequently. So whenever you see a system that has not been patched for long, the first thing that is called for concern is the vulnerability, which means the loopholes that hackers can come into. So it is good practice to make sure that every system is up to date with the most updated packages. So when you're having that conversation, you must say the fact that a system is not having an updated packages, the most updated packages, that's a whole breach for insecurity.
Okay.
So the number one reason why we patch and we have our system updated is for security reasons. Security is the top reason why we update, why we patch.
Okay, sir.
And so you cannot have this conversation about patching without you mention Why do you want your system to be updated every month?
For security reasons.
For security reasons, full stop. So in that work scenario, by the time you log in and see that this system have not been patched, the first thing you're pointing to them is the risk that we are facing to run a system like this that has not been patched. So the system is now verifying every patch, every package that have been installed. And then the last step is what? What do you have on your notes? What do you have on your notes when it comes to patching? The last step.
Check the new patch kernel.
Is that what you wrote down?
I took
after you run update, the next thing is check the new patch kernel.
No, reboot.
Reboot.
I think.
Okay, so let's reboot. If you do not reboot, your system will still be, you still have the same updates. So if we check, let's see, Red Hat release, just to make sure what we are saying is correct. If you do not reboot, what will you see? We still see 6.10. It has changed already. Wow, that's interesting. Can you guys see that?
Yes, sir.
Yeah.
Let's do uname-a. Okay, yeah, the kernel has not changed. So you still see a 431, correct?
Yes.
So other packages have been updated already to 6.10, but the kernel, which is the major man, as we said, is still showing a 431. So this is where reboot is required. So we type the word reboot, and we should be able to see that change at the level of the kernel now also. Make sense?
Yes, sir.
Yes.
Yes, sir.
Now, this is also a very strong proof that the packages are coming from the master. Remember, the master is running on a 6.5 itself, correct?
Yes.
But it's hosting a repository with a 6.10, true?
Yes, sir.
So the client who was also running on a 6.5 has now picked up 6.10 packages from the master and updated itself. So it is a blessing for you to update or to patch a server, reboot it, and it comes back up. You're supposed to go out, get a drink, and chill after that activity. I don't want to explain to you. Next class, we'll talk about the implications. Patching can make you call your home and ask them to bring dinner. So there's no way for you to even step out the office to go look for food.
I have a friend who gets so frustrated with working 11 to 7 p and doing patching.
So if we do a uname-a, yeah, we see that we have a kernel update now, correct?
Yes, 754.
From 431. So that's the amount of packages we have updated on this system. And if we go to our master has not updated itself. It still has not changed. It's still 6.5. And if we do a uname-a, yeah, our master is still on 431. Do we agree this is the master?
Yes, it's 240. Yes.
So let's patch the master also. If we say we should patch the master, what command should we run?
Can we just go directly to yum update -y?
Perfect. Who agrees with Ebude? Hannah is the name I keep calling Helen. Sandrine, are you there? Is she correct? How about Godfrey? What do you think?
She's correct.
Godfrey, are you there?
Yes, I'm right here.
Did you get my question?
No, sir. I'm not sure what the question was.
I'm suspecting you.
Get water, sir. No, I just
You're joining this bandwagon.
so I just stepped out to get water from the kitchen and
Oh, okay, I see.
get back.
Some people too step out to get stew sometimes. So the YUM update.
So what was the ask there? Sorry.
I can't even remember the question myself. Oh, we were saying that we want to patch the master also. So can you guys see my screen, right?
Yes, sir.
So I'm sitting on the master. So Hannah said we should just run YUM update. And Sandrine confirmed. So I was asking you if you agree to that also. So this time we're not going to do the -y so that we can answer to the yes question. So we see both scenarios. Does that make sense?
Yes, sir.
So we hit enter. Now, this is the person who is hosting the package itself. The repository sits here, but this guy was not patched. Can you see the irony I was trying to create?
Yes.
So the repository is just a location where the packages are found. That does not make you the host to be updated. So even you, the host, needs to be patched.
Okay.
So we say yes right here. Is it okay? You say yes or no. So we say yes, and then the patching begins. Any question up to this point? So we are done for the night. We are just running another patch session, which is going to be the same like what we saw for the client section. And nothing much to do. We can take questions or we can stop right here and we are good for the night. You guys want to stay and see this to the end? So let's do a recap as this is running. So we said patching is a very important activity, and as we said, our differentiation when it comes to the various environment is very important. So we're gonna run this again. Can you guys see my whiteboard?
Yes, sir.
So there are 3 environments. You have the development, you have the tests. Some companies they call the test QA or pre-prod. So pre-production. That's what I mean by pre-production, pre-production, before production. You see that test is before production, correct?
Yes.
And we ran some characteristics for this 3 environment. We said the developer environment is for everyone. It's like a playground. Everybody have access and they have both read, write, and execute permission. For the test environment, they are limited to read only. So they cannot VI and they cannot test. That's why whatever file they want to use in the test environment, they must put in a request so that admins can SCP that file for them, and then they can now look through what they have changed on their code. And if they are not satisfied, there's always that back and forth movement until the final copy is satisfactory, which is now what is moved to production. It is important for me to also make note that we do not just move files into production. There must be an approval process. That's what we call life cycle change and configuration change management. Let me put that on the chart. It's the process through which the code goes through before it is accepted to be moved into the production environment. Does that make sense?
Yes, sir.
Because production is where, imagine you're working for Facebook and you're working on Facebook and, you know, one day, by the time we wake up, you have moved one file that is very inappropriate to production and people want to log into Facebook. They are seeing and inappropriate stuff just because an admin has moved a file to production without our approval. Can you imagine the consequences?
Heaven forbid.
So you must make sure that what we call life cycle configuration change management plan, which means you will submit. Somebody's not muted. Which means you submit your reason why you want to move this file. You explain. A panel will sit, a panel of 2 or 3. You explain to them, what does this file contain? Remember, you did not even write this code. Developers did this code, but because you're the one doing the move, it is you who have to be able to make this adjustment. Or sometimes they may call you, and sometimes you may say, okay, you may invite the developer to come make that explanation because they are the ones who understand what is written in the code. Our job is to move the files. We may not even recognize how the code looks like because it appears as gibberish sometimes. Does that make sense? Do we have some database in the house? So it is your responsibility to go through this life cycle change management plan by, first of all, submitting that request, go to that meeting and explain to them what this change we do is going to improve. We say, for example, Facebook, we'll have to add some emojis on the homepage so that when users log in, they can see some new modifications since it's Christmas season, since it's Halloween, or maybe Thanksgiving. They say, oh, okay, that looks good. You can go ahead. Now they give the approval. With that, that's when now you can go and make that move and SCP that file. That way you are covered because you have had that approval. Does that make sense?
Yes, sir.
Where's our master? Where were we running? Was this the system we're patching? Doesn't look like. These clients, okay. Okay, memory map. So if we do df-h, what was the last command we run? Yum update. Yes, so this is what we're patching. Let me see if that got finished. All right, so the patching is finished. We are on 6.10 also. So another way to reboot is to do init 6. So instead of typing, you can either type reboot or init 6. They perform the same task. Does that make sense?
Yes, sir.
All right. So we're rebooting the master and we should be good for the night. So we are meeting next week, Monday. Make sure you come ready. You can bring your Christmas goodies to eat in class. That is permitted.
Okay, sir.
Any questions? There are no questions. So who do we have? Let me see. I don't have any system that boots halfway. That way we can perform how to fix that. Does anybody have any system that does not boot correctly? Sandrine, are you there? You want to share your screen?
Yeah. No, I don't have that system anymore. I deleted everything.
All right, so this is the solution. Let me explain the solution and you can try that anytime. Okay. For scenarios whereby your system is faulty and because of changes you must have made in etcfs tab, you remember the only way we get to the server backdoor is by rebooting the system and interrupting at the level of the grub, just like we did for password recovery, correct?
Yes.
So the steps remain the same. You function as though you want to recover password. And when you log into the command prompt again, instead of you typing password root, you CD to that location where you have your backup copy. So it's going to be CD to etc/etc, correct?
Yes, /f. Is it?
Yes, you're gonna go to /etc and you'll see your backup and the original.
Okay.
And then you rename your backup with the name of the original, and then you reboot your system again, and that will fix the issue.
Thank you.
Is that clear for everyone?
Yes, sir.
So for any faulty system, reboot as though you want to recover root password, interrupt the crop. That way you log in using the back door into the server, and then go rename your copy back with your original and reboot your system again, and you should be good to go. So our master is up. Let's log in. Okay. So if we do uname-a, that too is updated. No, that's not updated. It's 243. What happened here? etc Red Hat release. That's a 610. But the kernel is not. So we didn't have a kernel install. That's interesting. All right, we'll look into that next week. However, that's the steps and procedure which you need to do whenever you have a scenario where you need to patch your server. Any other question? All right, ladies and gentlemen, those of you who have not made your December payment, please try to do so that we can all be on the same slate, on the same page. Thank you very much and enjoy the rest of your evening. Good night, everyone.
Thank you, sir.
Thank you, sir.